Hey, afternoon, everybody. My name is Will Lawrence. I'm a senior taking a class called MAE 284. The assignment we have today is to take apart an assembly and see what aspects that we've talked about in class on orientation and GD&T apply. So I found this Mr. coffee maker. And sometimes I use it, but I don't use it often because it's loud and makes my roommates angry. So we're going to take this apart today, well, as much as we can. So from right now, you'll see it has a lid to cook or to keep the beans from splattering all over the place due to the inside impeller right there. The way it's activated is this little button is what will activate the motor at the bottom and beat the hell out of the beans inside, or whatever. There's not a plug anywhere nearby. Oh, yes, there is. It does work. And doesn't smell like it's on fire. So hopefully by the time we're done and put it back together, it will still be as functional. So the tools we'll be using for this job are a pair of vice grips, a pair of shitty channel locks that I found in my basement, and a screwdriver. So this is gonna be one take. If I make any mistakes, sue me. I don't care that much. So I'd say the first part here is the lid. The lid is concentric to the housing here to form a fitting that is flush with the outer housing. You have this button. This doesn't really come off, and I don't really want to take it off, but this would be the first component of it. If you're just looking for circularity, I definitely would check that. Yeah, and there's some other pieces that I'm missing as well. Thermomolded. At the bottom, you'll notice 3 Phillips head screws. So those taken out won't take too long. The bottom has vents for heat to dissipate from the motor, as well as little feet for the so this doesn't walk on the counter. The location of these screw holes is going to be very important. They won't be able to move around too much because they mate into counter bores down at the bottom. I'm not necessarily sure if they were threaded beforehand or if these were just forced into the soft plastic at the factory. I don't really have a desire to check what screw these are. I would imagine that they're probably metric, because the rest of the world uses a proper measuring system than the United States. But if that's that can be on topic for a different assignment. So there are 3 of those. All of the components will be taken and put on this paper towel here. However that looks, not really sure. So this section comes right off. So you can see the heat vents here, as well as the locational holes for the screws. These holes are counterbored, so the heads of the screws don't poke through. And yeah, those would probably be the features I'd like to control the most, as well as the circularity, sure, of this piece here, so that way it fits well with the inside and nests right here on this lip. There's also a section on the inside right here that has a rubber grommet or gasket, probably more of a grommet, that allows the motor to rotate freely and be balanced as well. This square section fits around the edges of the motor, keeping it in location. So probably, again, the position of this being very important, so it keeps the motor centered and doesn't cause the shaft of the motor to bind up or otherwise damage you spinning at 3,000 RPM or the cheap Mr. Coffee maker spinning at 3,000 RPM. So yeah, we're going to set that aside. Rubber grommet. The hole inside of this probably being important, or else this rubber grommet would not be able to fit in and nest securely. So I would say that the bore for that, the location fit for that, or the locational fit for that section is going to be important as well. On the inside, you can see that there is a switch, a fuse, and a motor. Up here in this section is a piece of plastic that is used to keep the cord pretty secure and stable. We're going to start removing these next. Yeah. Again, for all sorts of screws, these locational fits are the most important, being that they have to mate with other parts in the assembly. For this part, it doesn't seem to be super critical to the functioning of the device, rather just to keep things neat and orderly. These screws are of the same type as were pulled out of the bottom, likely to really reduce assembly costs. Let's get that out of here. And this is what that part looks like. You'll notice, oh, can you notice? Who knows? Sure. There's one hole, two holes. I'd say it looks like one of the holes is elongated as opposed to the other one. I'd imagine that's to account for any mistakes in the molding of the part below it, so that way the screw can shift around a little bit so it can fit as intended. But this is primarily a part to put tension on the wire, on the cable, and keep it in place. I'd say the width, the flatness of this wouldn't be super important. The size, however, probably would, because it has to fit in a small enclosed space inside of this assembly. The height, so it doesn't interfere with the cap above it. What would that be? I'll think of it soon enough. So going ahead, this is a little piece to protect the cable from the force put on by that tensioner, whatever it's called. And we can not pull anything out, because if you'll notice here, the impeller is still secured to the shaft of the motor, and that will need to come out first before we can remove this metal plate and thus the motor from the assembly. So to do that, take this pair of vice grips, open her up a little bit, and get them locked down on the impeller. I don't know if you can see that. And then we'll use this pair of vice grips, or this channel lock here, to loosen that. That impeller was really tight on there. I don't think I could have removed that with my hands. So there's the impeller. You'll notice the angle that it's been bent at on both sides. Two holes, not really sure what those are for, and that they're mounted in this piece of plastic here with a threaded insert on the inside. Definitely secondary. Looks like it was just press fit into that thermoplastic molding there. I would definitely have anything that rotates. Not necessarily this one per se, but we could throw on run out. As the professor said earlier, when in doubt, use run out. Sure, this one's probably important for that too. We don't want this moving at high RPMs and being unbalanced. It's light enough that it probably wouldn't matter, but it's fast, it's sharp, and I wouldn't want that flying out anywhere. So that's a motor. That's a lot of things going on in there that are not beyond the scope of this class, but I really don't want to take this apart and put it back together, so I'm not going to. Here is a switch. This switch is controlled. This switch is what's pushed on by the button at the top, right here, this one here, there's something that transfers the push all the way down here and connects the two copper leads in the back. And then here is a fuse. Don't overcurrent your electronics or they might explode or catch fire. Either or is not necessarily pleasant. If I was to say one thing on the motor, I would say definitely run out for the shaft. It would be incredibly important here. There's two contacts here, two brushes on, so it looks like it's a brushless DC motor, or it is a brushed DC motor. And if the run out on that is, or if it's too far out of spec on the run out, you're going to clash with your graphite brushes, and it's going to be unpleasant, as well as the keeping everything balanced here so it's not wobbling around and destroying the bearings or bushings that the shaft is housed in. With these, the holes that the shaft runs through, locational fits are incredibly important. Especially with a longer part, like it's maybe 4 centimeters long, and if those two are too far off, or if the holes are off in any amount, the shaft most likely won't fit. It's a small part, but the shaft is rather long in relation to it, so that's going to be important for sure. Put that down, unimportant. Lastly, you have the metal bowl that holds the beans. In this section you have a hole that the motor shaft runs through, and you have an upper lip here. Notice that it's not perfectly circular, and it's bent. It's bowed out a little bit. It looks like it was die formed, and when you insert this into the part, or into the housing, there's this little lip here. I don't know if you guys can see it too well. Little lip right there that it bumps up against. This section, this little rim bumps up against it and keeps it from going further in the part and keeping everything tight together. So the height of that little rim in here, it would be a critical section of this housing, and this rim is as well. Anyway, we took it apart, kind of talked about some of the things that we were going through and what were important with the fits and geometric tolerancing for this part, and now we're just going to put it back together and hope that it works. So I don't necessarily know if that's required, but you guys can hate it later. Initially, what I'm going to be planning on doing is top down and working our way back. So I'm going to throw in this tray, again keeping in mind that this upper lip is going to seat within this raised plastic rim section here, so that way it fits and doesn't move further up into the part. There we go. So that kind of has to be held in place with gravity right now until we can get the motor and the impeller to hold it in place. So I'm going to throw the motor in here, trying to keep it aligned so that it goes back in easily, though it will rotate, and it's not a huge deal. So once the motor's in, I'm going to just hold on to the shaft with vice grips so it doesn't move when I'm inserting the impeller. It needs to be a little more tightened. And then the impeller, again, is threaded somehow, and we can fit that right onto the shaft, the threaded shaft of the motor. So after that's fitted in, wires can go back where they belong. Switch goes in its hole. I'm also not a YouTube professional, so my apologies if this is substandard. These come around, fit into this section here. Well, that's probably why it doesn't fit. Excuse me. Then we have, once all the wiring is situated and back where it belongs, remember switch, fuse, motor. We can go ahead and thread on back on this little paper section, push it down, and then see how it keeps being, floppy and can come out of the section too easily. And not yet, again, that's the purpose of this little pressure piece right here. And again, because this is a little bit oblong, it allows for a little bit of wiggle room in the placement of the entire apparatus, or part rather, sorry. Again, the height of that piece right there is going to be very important, because we don't want it interfering with this lip right here, which is very close to the tops of the caps, and it just clears that, so the base plate can seat evenly and completely. So putting it back on again, the orientation, this setup here and this portion here, help keep the orientation of the plate and exactly where it's supposed to go. These two walls here, go on either side of the switch and hold that in place so it doesn't pop out of its located hole. And this positions the motor such that it's centered and that it is holding the shaft of the motor in place. Don't forget this little rubber grommet here as well. That again helps keep the motor more centralized than just the plastic bit, and also can absorb some of the shock of the vibration that is going on while the device is in use. There we go. So I suppose we can figure out if it actually still works or not. Ultimate question. It worked last time I did this. And it does. Wonderful. I love that. All right. Enjoy your trips to your living rooms. Goodbye.